Today we are going to look at some problems on our website. If you scroll down to the bottom of the plan, you will see them there. Now, a problem doesn't mean that it is something problematic, difficult to do. It is just a way of applying all the knowledge we gained and all the skills we gained over a week to a real situation, a practical situation. So let's look at our first problem. For our first problem, I have to calculate the area of two shapes. Let's look at our first shape, the one I've circled here. Now, it looks like there are three squares that measure 5 by 5 centimeters. Now, I don't have any little squares to count on those. What can I do? So, I've taken the square paper I have at home. You've got square paper in your numeracy books. And I am going to use these measurements to create a square. Now, I know that every square on my piece of paper is 1 centimeter. So I'm going to need 5 of these squares. Now, have a think how you're going to work this out in your books, because I don't know what the measurements are in your books. Will you need to measure 5 centimeters or will you need to measure 5 squares? I'm going to need a ruler, because don't forget, this is not an art lesson where I draw freehand. It's a numeracy lesson. I need a ruler to help me. And I'm going to count 5 centimeters, 5 squares. 1, 2, 3, 4, 5. And I need 5 squares this way. 1, 2, 3, 4, 5. I'm going to create my square. Remember, your shape and your problem is 3 squares like this, but we're going to look at the first one at the moment. So I know this is 5 centimeters, so 1, 2, 3, 4, 5 by 5 centimeters. 1, 2, 3, 4, 5. Now I could count all the squares, all the little squares in my square shape, but you know what? I've been counting so many squares, I'm getting a bit lazy. Is there a quicker way I can calculate this? If you notice, there are 5 rows of 5s. It's almost like an array, isn't that? 5 rows of 5. I wonder what that is. Let's have a look. 5 rows of 5. Think of your 5 times tables. It is 25. You can count them individually if you want. Now, because these, I know these are centimeters, and this is a measurement of the area, this is square centimeters. I wonder if you could see a pattern now. So we calculated 1 square. Your shape has 3 squares. I wonder what the area for the whole shape might be. This is the second shape of our problem. If you notice, it is a beautiful cross type of shape. Now, not all measurements are given to you. You will have to calculate some of them. So I have 5 centimeters there and 5 centimeters there, 15 centimeters, that is 10 centimeters. Oh, I think we need to stop and think about this. The more eagle-eyed amongst you will have realized there is something not quite right by the measurements. Now, 5 centimeters and 5 centimeters adds up to 10 centimeters, which tells me if the whole length here is 15, that surely is 5. But the horizontal line tells me it is 10. And here you come to realize that sometimes mathematics and graphics don't always match properly, or they don't always go well together. So here we have a situation where our measurements are right, but the graphic of the cross is drawn incorrectly, or that the cross is correct and our numbers are not right. Let's have a closer look. So here you can see that I've calculated that the right-hand side of the cross, as I look at it, should be 5 centimeters, because on the left-hand side it tells me the total is 15 centimeters. So if I calculate this correctly, that means that is 5 centimeters, and I've added it in red so you can see it more clearly. If the measurement at the top is correct, it means the measurement of the sides on either side of the 10 centimeters should be 2.5 centimeters, because 10, I take away 10 from 15, that leaves me with 5. If I share it between 2, that's 2.5. Now, this is fine, but it doesn't look right. This cross does not look right, so it will have to be drawn again, because in this picture the 2.5 centimeters looks the same length more or less as the 5 centimeters. It just doesn't look right. So this is what I propose we should do. Rather than getting involved with 2.5 centimeters and then when it comes to putting this on square paper, dealing with half squares, let's call the 15 centimeters, we'll cross them out and we will say there are 20 centimeters. This way everything else makes sense and our cross can look like this. So hopefully now you can draw this cross on your square paper, or see if you can calculate it without square paper help. The next problem is so much fun. What you need to do is cut out a piece of square paper, which will be 10 by 10, and you will have to make as many different shapes as you can which have the same area. It says here, start with an area of 10 square centimeters. One is done for you. It is the one that's shaded yellow. Are there any different ways you can have 10 square centimeters? And here we are. I've got my shape, which is 10 by 10 squares. So if I count it this way, there's 10 squares and 10 squares down this way. I want a shape that's 10 square centimeters in area. And there's one that's been already done for you. It's in your plan. There's 10 squares here. Is there another way I could do this? Can I get 10 square centimeters any other way? So what I'm looking for is 10 squares. Let's have a look. If I do 5. 1, 2, 3, 4, 5, I can do 5 more below it. There's another shape. That's area of 10 square centimeters. Could you do it another way? Have a go. Once you've done your 10 square centimeters, have a go at 6. Again, a simple way would be to draw 6 squares, or colour them in rather. 1, 2, 3, 4, 5, 6. So all the green area here is 6 square centimeters. Is there another way? Once you've done the 6 square centimeters, try it with 8. Try to see how many different shapes you can produce by doing that. For our next problem, we are going big. Let's see. What is the area of a field? 25 kilometers by 10 kilometers. What is the area of a netball court? 30 kilometers by 20 kilometers. What is the area of a playground? 20 kilometers by 10 kilometers. Wow, that's pretty big. Now, if you remember from the video earlier in the week, we said there's no paper big enough to calculate this in. So there are 2 ways we can go about this problem. Either by now you have noticed a pattern on how we calculate area. And don't worry if you haven't, it's really quite simple. But I'm leaving it to you to discover it. Or the other thing we can do is follow the advice I gave you in the earlier video, and we could agree perhaps that for each square in our square paper book, each square, instead of calling it a centimeter, we will call it a kilometer. So this way we can count things more easily. So for every square in your book, that will be a kilometer. How many squares are you going to need to make 25 kilometers? And then how many to do 10 kilometers? And then you could calculate your area that way. I hope you have fun with these problems.